Okay, so let's carry on from where we were last time, and I just wanted to show you a little something before we carry on to question 6. You'll notice that when we answered question 5, we used up about that much space on the page, and you've probably noticed that when you did it, you had that, and then you had another whole page here, and it might have sort of made you a bit scared that you weren't doing very much if you'd just done that little bit there. They do give you a vast amount of space to do these things, just in case you mess it up or you want to cross it out or whatever. So don't worry, think about it. It's got 7 marks, so they're looking for 7 things on here, and there's pretty much what we got: 1, 2, 3, 4, 5, 6, 7 lines of code. So you can't expect that much more for that many more marks. So don't be frightened by the vast amount that you'll see on there. Now let's move on to the next question. Now again, the last time I did this, my computer decided to crash on me again. So let's thankfully I've got a new computer to work on now. So let's have a look at the question 6. So question 6, here we are. We've got this sorting algorithm here. So sorting, so putting things into order. Array indexing starts at 0. So if you look up the array variable here, the indices on it start at 0. So this is at position 0, this is position 1, this is position 2. Let's have a quick look through and see how this is going to work. So we start out with a variable. Sorted is assigned the value false. So we've got a variable that's going to tell us whether it is sorted or not. So at the moment we're going to say it's not, so it's false. And we're going to keep repeating, so iteration here, while sorted remains false. So as long as sorted is false, in other words, as long as the array list here is not sorted, we're going to keep repeating this part here. What we're going to do, well, first of all, we're going to set sorted to be true. Only if we do any swapping around are we going to say it's not true, so and then we'll set it back to false. I, which is going to be our index for the array, is set to 0, so we're going to start at the beginning at 0. While, now we've got another while loop working inside this while loop. So this one will repeat and repeat and repeat, and when it gets to the end of that, it'll go back to here. That will repeat, 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 back, repeat, 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 back, and so on until this one is finished. In other words, until we've sorted it. So while I is less than 2, in other words, we'll keep repeating this as long as I is less than 2. And that's not surprising because we've got 2 things up to number 2 in the array. So what we're going to do, if the array at position I plus 1, well, we're going to start with I as 0. So 0 plus 1 is 1. So what is at position 1? Is it less than what is at position I? Well, we know I is 0, so at position 0. Is what is at position 1 less than what's at position 0? Is what's at position 1 less than what's at position 0? Yes, it is. And if that's so, then we're going to do some swapping around. We're going to put what's at position I, 0, into a variable called t. That's t for temporary. So they're going to put that 4 into temporary. Then we're going to take what's at position I plus 1, so that's what's at position 1, and we're going to copy it into position 0. We're going to take that 1, put it in there. So they're now both going to say 1. But we haven't lost the 4 because it's in that t variable there. Then we're going to take what's at t and put it into that position there. So the 4 goes into there. And we're going to say that sorted is false, because the fact that we've had to make a swap means that it isn't sorted. Then we're going to make I equal to I plus 1, so I will become 1. Back we go. Is I less than 2? Yes, it is. And so on and so on and so on and so on. Okay, let's proceed onwards. What's the data type of the variable sorted? Well, sorted is set to false there and true there. What kind of variable? Can only be true or false. That's a Boolean variable, preferably with a capital B, but don't worry if not. Next question. The identifier sorted is used in the algorithm shown in figure 2. Explain why this is a better choice than using the identifier S. Now, first of all, 2 marks. Explain. When you explain something, you've got to give a reason for it. So I'd expect to see a because in there. Why would we call it sorted rather than calling it S? We've got this T and this I, so why do we call this one sorted rather than S? Well, if you think about it, we were able to work out, weren't we, what that's for. It tells us whether the list is sorted or not. So therefore it's giving us actually information about what the variable's for. And if later on somebody else is coming along and wants to work out what to do with your algorithm, then it makes much more sense to them if it's got a sensible name. So we can say this, the purpose of the variable is clearer. So the purpose, what is the purpose for, and why is it clearer? Because it describes what it is actually used for. So we've said what the reason is for calling it sorted, and then why that is. We've got a because there, so that explains why it's a much clearer variable. Okay, let's move on. We need to start getting the pace up now a bit, I think. So that's got rid of that and that. So let's have a look at 6 part 3. So 6 part 3, shade 1 lozenge, show which of the following contains the false statement about the algorithm. Right, so that needs to have the algorithm back again. Let's put it down here somewhere. Here we go. So let's just have it in front of us, just in case we need it. So the algorithm uses a named constant. Now remember, a constant is like a variable, but it doesn't change. Is there anything in here that is constant throughout? No, all of them change all the time. So that one is false. So that looks like it could be the right answer. Let's just check the other ones. The algorithm uses indefinite iteration. So indefinite iteration means repeating where we don't know whether we're going to stop or not. Yeah, we're using a while loop. Whiles, in fact we've got 2 whiles, so we've got indefinite iteration there, that's true. The algorithm uses nested iteration. That's where you've got one loop inside another loop. And yep, we've got one loop here inside another loop. So those 2 are true. The one that's false is the fact that we're using a constant. We are not. Okay, now time to do some a trace table, bit of tracing of our algorithm. So let's work our way through. So I think what I'll do is I'll just fold this over so we can just have the algorithm here and try and get it so we can see both at the same time. Okay, so at the start, here's our array. It's got number 4 at position 0, number 1 at position 1, and number 6 at position 2. Sorted is set to false, so these 2 are. So let's work our way through it. While sorted equals false. Does sorted equal false? Yes, it does. We set sorted to be true. That's there. We set I to be 0. While I is less than 2. Is I less than 2? Yes, it is. If array position 1, I plus 1, well, I is 0. 0 plus 1 is 1. So while what's at position 1 is less than what's at position 0, I is 0, we've already established this, that yes, that one is less than that one, then. Right, what do we put in T? At T, we put what's at array position I. I is 0, so what's at position 0? 4 is at position 0, so we put that into T. Okay, we've done that. Now we move on to here. We take what's at position I plus 1, 0 plus 1, 1. What's at position 1, and we put it into the position 0. We take what's at position 1, we put it in position 0. Then we take what's at T, and we put it into what's at I plus 1. So what's at I plus 1? I plus 1. 0 is I, 0 plus 1 is 1. We put it into position 1. So we take the 4. So basically, we just swap the 2 over. We can't just literally pile one into the other because otherwise we'll lose one of the values. What happens next? Sorted is set to false. So we set sorted to false. Okay, we set I to be I plus 1. I becomes I plus 1. 0 goes to 1. And we come to the end of the while. So this while here, we go back up here. Is I less than 2? Yes, it is. If array position I plus 1, so I is now 1. So we take what's at position I plus 1. That's 1 plus 1 is 2. So what's at position 2 is what's at position 2 less than what's at position 1. Is what's at position 2 less than what's at position 1? No, it's not. In which case, we can ignore all of this code here, all of this here, go to the end if I becomes I plus 1. 2. End while, back we go. Is I less than 2? No, I is not less than 2, in which case we finish the while loop. Now we come to this end while, back we go. Is sorted equal to false? Sorted is equal to false. Right, we're back in the loop again. We set sorted to be true. Let's go down to here, just to make everything a little bit clearer. Okay, sorted is true. I is set to 0. So can you see what's happening now? While I is less than 2. Okay, is I less than 2? Yes, I is less than 2. If array I plus 1, so 0 plus 1, if what's at position 1 is less than what's at position I, which is position 0, is what's at position 1 less than what's at position 0? No, because this is now 4, this is 1, so it's more than. So we can ignore that whole if part because they aren't so, and we can set I to be I plus 1. Notice that sorted is still true. Back we go round this while loop here because we're in the inside one. Is I less than 2? Yes, I is less than 2. Okay, let's have a look at what we do now. Is array I plus 1 less than array 1? Well, I plus 1, I is 1. 1 plus 1 is 2. So what's at position 2? Is it less than what's at position 1? Is what's at position 2 less than what's at position 1? No, they're in the correct order. So in which case, we don't do any of that. We ignore that, and we go to here. I becomes I plus 1. Now, end while here, back to here. Is I less than 2? No, it's 2. Finish this loop here. End while, back up to here. Is sorted equal to false? No, it's true. In which case, we come out of the end of this while loop, and we're finished. And that's what your trace table should look like. Moving on. Okay, a merge sort. Now we did the merge sort at the end of last year. So hopefully you'd have done your revision, had a good look at that. So the one we did before was the bubble sort. This one is your merge sort. So with a merge sort, what we do is we break up everything into individual units, and then we sort the individual units, and then we draw them together. So 7 and 3 will be sorted as 3 and 7. 1 and 4 will be sorted as 1 and 4. 2 and 8 stay the same. 5 and 6 stay the same. Then we merge the next part. So we merge this here, so that becomes 1, 3, 4, 7, and this part here 2, 5, 6, 8. And then last of all, these get merged into each other to make the sorted area. Now, one advantage of a merge sort just state, so we literally have to just state, so we can say it requires less processing. You could say that the loops don't go round so many times. The one we did before with the bubble sorts, it had one loop inside another loop, so loads and loads of processing going on. This requires a lot less processing. The programmer implementing the algorithm in figure 2 decided to create it as a subroutine, so by decomposition. Line 1 was removed and the array was made a parameter of the subroutine. State 2 reasons why the programmer decided to implement the algorithm as a subroutine. Well, why do we break things up? You could say it's easier to program individual parts. Or you could say something like, if there's an error, it's easier to spot. And let's give you a third and a bonus one. So you could say something like, the program can be updated more easily. If you know what each part does and you want to change one aspect of it, you only have to change that part of the program. You don't have to change the whole program. Any two of those three will get you the marks. Okay, blank page, have a little rest, move on. Writing an algorithm. Okay. So let's see. Now, develop an algorithm using either pseudocode or a flowchart. Well, we're going to go with a flowchart route that allows a taxi company to calculate how much a taxi fare should be. Right, it gives you a whole list of things to do, and by doing these, we should be able to work our way through. 8 marks. So again, don't be scared by the fact that on there you've got another whole blank page. You can fit this onto just this much here. So don't worry about that. Let's work through one stage at a time. Basically gives you what's happening. So you just got to follow the pattern here. Right, the algorithm should prompt the user to enter the journey distance in kilometers. So prompts the user to enter. So we know that entering is a user input. So what should we call the variable? Let's call it distance. Okay, we'll call the variable distance. You can call it km, you can call it kilometers if you want. So it's going to ask for a user input to put into a variable. The distance entered must be greater than 0. The user should be made to re-enter the distance until the distance entered is valid. Right, so it's going to keep asking you. As soon as you know it's going to keep asking, you know that we're talking about a loop. Do we know how many times they're going to get it wrong? No, we don't, so we're going to use while. So if they've made a mistake, so distance has got to be greater than 0. So if distance is less than or equal to 0, so if they've put in a distance that's less than or equal to 0, we'll ask them to type it in again. Okay, that's and we'll put an end while there. You could put in a thing saying about an error message, but it doesn't tell you to do that, so don't worry about it. Okay, so we've done the whole of this first part now. Next, prompt the user to enter the number of passengers. No validations required, so we can just accept the number of passengers. Again, remember, if you simply somewhere in here get this and this, that's a couple of marks straight away out of the 8, even if you can't think of anything else to do. Calculate the taxi fare by charging £2 for every passenger, regardless of the distance. So fare is 2 times passengers. And we charge £1.50 for every kilometre, plus 1.5 times distance. You can do it as 2 separate steps, but I'm going to do it all in one go to save time. Output the final taxi fare. Output fare. So we've asked for the distance, we've kept asking until they typed it incorrectly. We've asked for the number of passengers, we've worked out the fare, and we've outputted it. 8 marks. Bang. Okay, let's get rid of that. These pages seem to be going down in number, that's good. Okay, truth table. Nice easy truth table for the AND logic gate, remember. AND only works if A and B are both switched on. The only time that's happened is there. Every other time the output's a 0. AND gate. Okay, move on. 10-second job. Okay, let's look at this. Logic circuit is being developed for an audio advert in a shop that plays automatically if a customer is detected nearby. The system has 2 sensors, A1 and A2. There they are, these 2 here, that detect if a customer is near. The audio plays if either of these sensors is activated. Either this one or this one. This one or this one. Right, immediately we know that's an OR gate. Okay, so this one or this one. Right, the system should only play if another system, S, is not playing. So it's got to work if that one's, so if that one gives you an output and this one doesn't give you an output. So we know that it's got to be this one and something about this one. So AND gate, but it's when this one is not playing. Like so. So either one of those and not this one. 3 marks. Okay, now this one is one that you can do just by using a little bit of logic, if you think about it. Okay, we've got 3 subroutines. Block on top, whatever the column number, it tells you what you've got on the top. So in this case it would be block on top of 0 would be C. Move source to destination. Move the block on top from there to there. Height of a column tells you how many blocks are on that column. Okay, let's work our way through. So, looking at this one, try and make sure it's all on the screen. There we go. This is how the blocks A, B and C, so A, B, C. Draw the final arrangement of the blocks after the following algorithm. Move 0, 1, move 0, 2, move 0, 2. So we're going to move 0, 1. What's on top at 1 is C. We're going to move it to 1. So we're going to end up with C. You can draw the blocks if you like. I'm just going to write the letters. Move 0, 2. Now we've moved C, so we've got B on top. So we're going to move what's on B to position 2. Now we've moved C and B off and we've got A left on top. So now, it might help you just to cross them off as we go along. Now A's on top. What do? We move 0, 2. So we move A onto the top of 2. So that goes on top there. Bang, 3 marks. Okay, now it's going to get slightly more complicated. Let's look at the next one. Here we go. So now we've got to start with these here. While, so remember, a while loop will keep repeating as long as something is true. While the height at position 0 is bigger than 1. Okay, is the height at position 0 bigger than 1? Yes, it's 3. So what do? We move 0 to 1. So we move what's on top of 0 to 1. So we're going to move C to here. Cross it off of there so we know it's gone. End while. Back we go. Is the height of 0 still bigger than 1? Yes, it is. There are two things on there. So we're going to take what's on top of 1 and move it to 0 and move it to 1. So that will be B. Move to there. Okay. End while. Back we go. Is the height of 0 bigger than 1? No, it's 1. So now we're not going to do that. We're going to move what's on top of 1 to 2. What's on top of 1 is B. So we're going to move that off of there. Going to move it to there. A is still on there. And there we go. A, C, B. Last one. Now this is where life gets a little bit more complicated. So we start with CBA again. Draw the final arrangement of blocks. For C is from 0 to 2. In other words, C starts at 0, then it goes to 1, then it goes to 2. Definite iteration. If block on top of 0 equals B, so C is 0. If block on top of 0 is B, is the block on top of 0 B? No. Then, well, we're not going to do that because it's not B, so we're going to do the else part. Move from 0 to C plus 2 mod 3. Right, let's work that through. C plus 2, well, C is 0. 0 plus 2 is 2. 2 mod 3. Mod means the remainder when you divide. 2 divided by 3 is 0 remainder 2. There are no 3's in 2, so that's 0 remainder 2. So the remainder of that is 2. So we're going to move from 0 to 2. What's on 0? C. So we're going to move from C to 2. Okay, so C has moved to 2. Make sure you can, there you go, make sure you can see that. Okay, next. So we've reached down to here. So now we're going to go back around, and now C is 1. We started at 0, so it moves to 1. C is now 1. If block on top of 0, oh, let's cross that C off there. If block on top of 0 equals B, does the block on top of 0 equal B? Yes, it does. Right, so we're going to move 0 to C plus 1 mod 3. C is 1. We've reached 1. So C plus 1, 1 plus 1 is 2. 2 mod 3. Well, again, it's the same as last time, isn't it? Divide by 3 and the remainder. 2 divided by 3 is 0, remainder 2. So C plus 1 mod 3 is, so we're going to move 0 to 2. What's at 0? At 0 is B. So we're going to move B from 0 to 2. Cross it off to tell us it's gone. Back around we go again. Now C is now 2. That's the last one we're going to do because we've reached the end of the numbers. So C is now 2. If block on top 0 equals B, does the block on top at 0 equal B? No, it's A now. So we take C, which is 2. 2 plus 2 is 4. 4 mod 3. 4 divided by 3. There is 1 3 in 4 and remainder 1. So what's the remainder? The remainder is 1. So we're going to move from 0 to 1. We move what's on there, which is A, and we move it to column 1. Done. Okay. It's done. Over the page. And this time we've got to write one of our own. So what we've got to do is we've got to develop an algorithm using pseudocode. Your algorithm should work however many blocks. So don't just do it for 2 blocks. We've got to know it's as many blocks as there are on column 0, you may assume there'll always be at least one block to start with. The order of the blocks must be preserved. You mustn't change the order. The move subroutine must be used to move a block from one column to another. You should also use the height subroutine in your answer. So we've got to move everything from column 0 to column 1. Now we can only move them one at a time. So we can't just take what's at column 0 and stick it on column 1. We have to move the blocks individually. Now obviously we can't just take what's there and move it there, because then they'll be in the wrong order. It'll be B and then A. And we don't know how many of these there are. So we're going to have to keep repeating. Now let's think about this. We don't know how many blocks there are, and we're going to have to keep repeating. Well, that sounds like a while loop, doesn't it? So let's start off by doing a while. And when's it going to stop? It's going to stop, isn't it, when we've got rid of all of these blocks. So if we say while the height of column 0 is bigger than 0, then that will keep repeating until when finally there are no blocks left here, then the height will be 0, so that will stop the loop going round. So there's our first thing. Now how are we going to get them to be the same? Well, the way to do it is to take these and put them onto column 2 and then put them back on number 1 here. So how are we going to do that? Well, we're going to move what's on column 0 to column 2, and then what's on column 2 to column 1. So all we have to do now is we have to say, yeah, we're using the move subroutine. We've used the height subroutine, so that's fine. So all we're going to do is we're going to do move 0, 2, and then move, I got it on the there we are, then move 2 to 1, end while, and that'll do the job. Think about it. At the moment up here, the height is the height of 0 bigger than 0? Yep. Okay, we're going to move B to there, then we're going to move B to there. Okay, that's taken the B off. Is the height greater than 0? Yes, it is. Right, we take the A, so the B will now be here. We take the A, we move the A to here, and then we move the A to there, and it's worked. It's as simple as that. Again, don't worry, they give you a ton of stuff to do. And finishing off with number 10. Another nice little trace table just to finish us off properly in every sense. Okay, the subroutine is used to authenticate a username and password. Array indexing starts at 0, line numbers included, don't worry about it. So we will send the subroutine two parameters, user and pass. Okay, so we'll get the user, we'll get the pass, the person will send that to us, and we'll check it against these two lists here. Check US, I presume, means user, PS means password. Okay, so complete the trace table for the following subroutine call. So if we send it, Alice, which will be the user, and woof 2006 will be the pass. Okay, so let's work our way through the subroutine here. So we start off, Z starts off as 0. Correct starts off as false. Then we do while Z is less than 3. Is Z less than 3? Yes, it is. It's 0. If user, well, user we know is Alice. So remember, that's user. That's pass. If user equals the same as USZ, well, Z is 0. What's at position 0? Dave. Is user equal to what's at position Z? No, because user says Alice. Then don't need to do any of that. And if Z becomes Z plus 1. End while, back we go to the while. Is Z less than 3? Yes, it is. It's 1. if user equals USZ. What's at USZ? Alice is at position 1. So it is the same. Right, we're going to have to do this then. If user equals USZ, then if pass equals PSZ. Z, remember, is 1. The pass they've typed in is WOOF 2006. What's at PS position 1? WOOF 2006. Okay, if that's the case, correct is true. End if, Z is Z plus 1. Z is now 2. Unfortunately, we're going to have to go back and do another one. Back we go around again. Is Z less than 3? Yes, it is. We know that user can't possibly be the same as, because it's another one, Bob. So that means we can jump over there. Now make sure you do this. Z becomes Z plus 1, which is 3. End while, return correct. Correct is sent back as true. There are your 3 marks. Okay, we're going to need this algorithm. Okay, state the value that is returned by the following subroutine call. Authenticate Bob ABF32. Well, if we look, Bob, he's next to exclamation marks. So we know that those two things don't go together, so it must send back false. Lines 7 and 8 in figure 3 could be replaced with a single line. Shade 1 lozenge to show which is the correct new line. Right, let's think about it. It's only going to accept you in here if you match here and you match there. So this is something where both of them have to be true to be correct. So it must be if user is that and passes is that. There's no knots in there, so it has to be one and the other. So it's the one with an and in it. A programmer implements this subroutine. He replaces line 9 with return true. He also replaces line 14 with return false. Now notice we don't return here until we get right to the end. But if instead of saying that correct is true, we just send back true, think about it, that will end the subroutine without having to keep going round and round and round. So, how has he made the subroutine more efficient? In which case we can just say it will not waste time because, explain, because it finishes when it finds a correct match. And that's that. There's your final question.